Okay, today we are going to learn about voltage divider circuits, and we will use them when we learn about thermistors in our next class. So let's have a look at what a voltage divider circuit looks like and what we're trying to achieve. So it's a simple series circuits with two resistors in series, and we have a power supply. Let's call it the V input because that's the input supply that we are providing to the both resistors. And we know that in series circuit the voltage is shared, so a part of that voltage will be given to R1 and a part of that will be given to R2. So in this circuit we're trying to get to a shortcut formula to find the voltage drop across both resistors. So let's say we are interested in finding the potential difference across R2, and we're going to call it V output. So we can use Ohm's law, find the total resistance, and then find the total current, and then find the PD across each resistor. But there is a simple formula that we can work out, and then use that formula to work out the potential drop across both resistors. So let's figure out that formula. So let's say the current in the circuit is I. Now we know that total resistance in the circuit is R1 plus R2 because it is a series circuit. So using Ohm's law, V equals IR. So the total current will be equal to V over R. What we are applying is, we've labeled it as V input, and R is the total resistance, so it's R1 plus R2. So this is the formula for the current in this circuit. Now, what will be the potential drop across R2? That's V output, right? So V output would be current times R2. So using Ohm's law, we need to now find the V output. What is the potential drop across R2? So let's put so R2 times I. Instead of I, I'm going to put this here, V in over R1 plus R2. And that gives us the formula for the output voltage in a voltage divider circuit. So V output across a resistance R2 is R2 over the total resistance, that's R1 plus R2, times input. So that is the formula for the potential drop across R2 in a potential divider circuit. Similarly, if we were finding the drop here, V1 will be equal to, again, it'll be equal to R1. So which resistance are you finding the PD across? Over the total times what you're supplying, input. So basically the potential drop across any resistor series is that resistance, R1, whichever you're measuring the potential drop across, over total times the input. And that is the formula that you'll be using when we do thermistors. So hope that makes sense.